Okay, so in this example, we have that our mean is 10 and our standard deviation is 2.5, and we want to find the probability that x is less than 14 and the probability that x is between 8 and 14. And we know that we have a normally distributed population. So we're going to use the formula that we had back in chapter 2 for z-scores. Z is x minus mu over sigma. So we first need to convert this 14 using our z-score. So we're going to have z is 14 minus our mean 10 divided by 2.5. And remember your order of operations, you've got to do the 14 minus 10 first. So we'll have 4 divided by 2.5, that's 1.6. Now, recall from section 5.2, when we looked things up on our z-score table or our standard normal table, if it was z is less than a number, we could just read it off of the table. So equivalently, this is really z is less than 1.6, and we can go to the table and look up 1.6. So let me pull up our table. And let's find 1.6 on the left-hand side. Now I'm in the negatives at the moment, so let's see. Positive part of the table. 1.60 essentially, so 0.9452 on the table. All right, now for our second question, we would normally do our z-score for both 8 and 14, but we really already have the z-score for 14. So let's go ahead and compute it for 8. So z is equal to 8 minus 10 divided by the standard deviation 2.5. And 8 minus 10 gives us negative 2 over 2.5. And negative 2 divided by 2.5 is negative 0.8. So again, let's look up that value on our table. But recall from what we did in section 5.2, if we have a value between 2, or we have an x between 2 values, we're going to subtract what we get from the table. So we already know the answer for 14. It was 0.9452. And now let's look up negative 0.8 on the table. I'll need to go up to my negative part of the table. Negative 0.80, so negative 0.8, 0 is our first column, 0.2119. And if we subtract those two, we get 0.7333.